So this is what we were looking at in the previous class. So now we will see examples of all of these methods. But the first one, and very popular one, is called classification. Classification would take the data and assign a class to it. By a class, we mean there is a special attribute or column in the data, usually in the end of the data, that helps us to make a decision. It's called a decision attribute or a class attribute. For example, if let's say this is some kind of financial data and the bank is collecting this data on their customers and they are collecting certain information like what the customers are buying, what did they enjoy to spend, where they enjoy to spend their money, do they buy a certain clothing or go to certain restaurants or certain gas stations and whatever, are they actually paying their bills when they use the credit cards, are they paying them on time? They would create certain profiles for the customers, how old they are, where they like to go, what they like to do, and where do they live, what is their, let's say, their education. And then from this information, they want to find out, is this customer low risk or high risk to pay their credit cards? Should we give a credit card to this person? So they have a class that says, yes, give it, customer is fine, or no, do not give it, customers are high risk to not make the payments or repay back the credit cards. So they assign two classes that help them to make a decision. So they're making a decision here. Should we give the credit to this customer or not? Now, this is a financial example. This method actually would work with any data, and the method, machine learning method, doesn't really care about the data. Is this financial customers? Are these medical patients? Are these students in educational data? Is this a government data about the taxes that people pay? Or what in the world the data is? Doesn't make any difference. The meaning of the data is not important. This method works on any data because he doesn't understand what the data means. He just trained to find the class of the data. So the class can be a simple yes or no answer. For example, with medical data, does this patient have heart disease or not? Class 1 is yes, has a heart disease. Class no is not, he doesn't. Now I'm just giving example with two classes, but he can be having 3 or 4 or more than that. For example, does he have cancer? Yes or no, but it can be benign, malignant, or anything in between. So they can be class 1, 2, 3, 4, 5. Benign, light, benign, heavy, malignant, light, malignant, heavy. Healthy patient, cancer. So all of those could be classes. It can be 4, 5, 6, or even a lot more class values. All right, so this is medical data. This could be student data for students and professors. What teaching methods to use or what makes the classes more effective. What would improve the student learning experience? Is it some active learning teaching method, or is it that they like to work in groups, or is it the campus facilities, or what? So the data can be anything. Point of the matter is we will assign a class. Yes, this improves the student learning, or no, it doesn't, or anything in between. It improves it on a scale from 1 to 10. So there are 10 possible classes here. Classification, whatever method it uses, is going to assign the class. The regression, which is what we have today for our assignment for week 2, will map a data item to a value that is a prediction variable. So the regression, that's why it's called a regression, is because it looks at past data and what happened in the past. And based on what happened in the past, it's going to make a prediction of what is going to happen now or what's going to happen in the future. So it looks at past data and to try to determine a prediction by assigning a certain value to the data item. There are other methods that will discover deviation and change detection. You might have noticed something the banks are doing with the credit cards. Let's go back to those guys. So let's say we go to travel to Europe or to China or another country and we use our credit card and we buy something over there. Most likely what's going to happen, they will say, your card has been restricted. We think there is a fraud. Is this really you? You don't really buy things in China and in Europe. And what is going on here? So the bank is going to block our card because there is something here that's not usual. There is a change. They have detected a change. This kind of change that is different from the normal data values or things that we normally do is called an outlier. So the outlier can easily be found because he is a data item that's very different from the rest of data items. If we are just to plot and visualize the data, all the data items are over here. All of a sudden, one dot is in the middle of nowhere to the top right corner of the visualization. That's the outlier. Because the values of his attributes are very different than the rest of the data in our data set. Data records in our data set. So this is easy to find. So the banks are doing it. Hopefully, they will protect their customers. But the other method that we will be studying is called clustering. Now, those methods we just seen over here, classification, regression, and deviation, those are called supervised learning because the machine is learning with our supervision. We are giving the past data and say, look at this, that's what happened in the past. Make a prediction about the new item that came in. Is it similar to any of the ones in the past? What did they do? Well, likely this one's going to do the same thing. So here you go. We are giving it some data and asking it to learn from the examples that it has seen before. Classification especially is doing that. Here are the healthy patients. We have like thousands and millions of them. This is the values for their age, their location, their education, everything else we want to know about them. Based on these values, a new person comes in with the same location, with the same education, with the same age. Guess what? They're going to be in the same class. So it's easy to teach the machine like this. Now, over here, we have something called unsupervised learning, where the machine is learning on its own. We are not guiding it. So this means finding clusters. This means that it's just going to examine the whole data and group the items into clusters or groups of similar values. And it can do this on its own. Doesn't need to look at past data. We don't need to train it or test it, anything like that. We just give it the data and say, go ahead and find groups of similar items in here. Let's say we want to group all pages in the internet, web pages. Here's going to be pages related to cooking and food. Here's pages related to education. There's pages related to medical stuff, financial stuff. It's going to figure out which pages are similar to each other and put them in the same group. We also have dependency modeling methods. These methods would look for correlations in between the data items. Let's say one patient was healed from the cancer. How is that going to affect the others? Can he help the others? Can he affect them with his healing? We will study this kind of dependencies and correlations. Let's say one item changed. Customer is of high risk if he's very young. Let's say he's a teenager and he lives in a specific neighborhood and he's and has certain friends and he's of a class, or she is of a class high risk. Well, let's say this person changed. They grew up, they got a master's degree, they moved to a different area. Guess what? Now they're similar to the class of low risk and safe customer. Something happened here. Something changed. Because of that, it is correlated to the values of the rest of the attributes, and it can change the class or it can change other values in the data. So this kind of dependencies and correlations can be studied with the dependency modeling. And then we have a summarization. Summarization is important because if we're dealing with big data, let's say we have some data that has millions of records. We can run for classification, regression, stuff like that, clustering, and we're going to end up with 100 clusters of stuff we have to look at. Who's going to read through all that stuff? We're going to get a million results from classification and clustering because we run it on a data with millions of records. You see this little guy on here? He is like, what am I supposed to do with all of these results I got from the machine learning algorithm? It's too much. It's way too much to read through. It's millions of results. So it is important to do a summarization. Summarization, it's just going to present the essence to the user of what is the most important thing that we learned from this machine learning algorithm that is going to help them to answer their question. Should we give the loan to this customer or not? Or what to do to heal the cancer for these patients, or what to do to improve the education of these students. Whatever we're trying to discover from the data, the reason why we collect this data can be summarized. So only the most important essential part, the wisdom, the actionable knowledge, is presented to the user. So that's what we have in summarization. Since today we'll be looking at data preparation so all these methods are great, right? But these are computer programs. So let's go to the Python Keras library. It has all that stuff. We can call this one, we can call that one, we can call that one. But it expects the data to be in a certain format. Let's say it takes a flat text file. It needs to have 7 attributes. Exactly the last one should be the class one. It should be a yes or no, or if it's got 7 classes, you have to tell it how many classes does it have. If you want to run clustering, you want to tell it how many clusters to produce. So the preparation of the data is important. We have looked at this picture last time briefly, but first of all, we want to know what are we looking for? What is our goal with this data? The second thing is prepare the data. If it doesn't exist, collect the data. If you want to use one that already exists, prepare the data for giving it to the machine learning algorithm. So if it expects a flat text file with where the names of the attributes are on the top and the class is on the right side, or it's comma delimited, or if it is tab delimited, or what in the world this code expects our data to look like, we need to prepare it before giving it to the machine learning library for processing to make sure that it will take this input, it will run, and actually produce some result that makes sense to us. So the pre-processing is important, and we need to choose which of the methods we'll be using, which machine learning methods. And that's step number 3. And number 4 has to do what we just mentioned earlier. What if we get millions of results? Who is going to read through millions of pages of results that we got from this data mining algorithm? So interpret and evaluate what we discovered. Is this useful for us? Can we summarize it? And what are we gonna do with this knowledge? Do we now know which customers are high risk and low risk? Can we go ahead and use this knowledge to issue them the credit? Or do we learn how to heal the cancer now for these patients, or how to improve our education methods? Put the result in a practical use. So the point here for chapter 2 for this week, what we are given to study is the preparation of the data. What does the preparation include? As I just said, first of all, data need to be formatted in the correct format that the machine learning algorithm will take this data and run it. Because if it's not formatting correctly, it can give errors or it can crash and it's not going to do anything. So to prepare the data, there are certain tasks that need to be done. First is the formatting of the data, and then they are more quality-based tasks. Let's say the algorithm needs to know it doesn't work with null values. If certain values are missing or equal to null, it might crash, or it doesn't use them or include them into the analysis and into the results. So because of that, we need to check the data during the data preparation or data cleaning, see if it has missing values, either fill in the missing values or remove those records so they're not affecting the analysis. There are certain algorithms that can try to determine what is the value supposed to be according to the raster records and fill it in. Noise data. Okay, so noise data could be data that is incorrect, that has been entered by mistake or by people not wanting to provide the data and giving like fake data that's not true about them. We can figure that out, and this is called noise, and eliminate the noise from the data before we start. Another thing that needs to be done, especially for clustering and classification, is to normalize the values. Values need to be transformed or normalized to match the, let's say, interval of the rest of the values in the rest of the attributes in this data. Because let's say most of the attributes have value between from 1 to 10 or from 1 to 100. Attribute 1, 2, 3, 4, 5, all of them look like this. All of a sudden, attribute 6 is having values of 1 million, 5 million, 25 million. That's very different from the first 5 attributes. And if we take an average, guess what? It totally skew the answers. So if we're going to be doing certain using clustering or classification, we might need to convert those millions by transforming them to a similar value as the other 5 attributes. So 1 million will be mapped to number 1, 2 million to number 2, 3 million to number 3, and we'll transform them to look similar to the others, so they will not be skewing the analysis. Create derived attributes. If we think we don't have the appropriate attributes to answer our question, we might need to add more attributes that make sense to be able to answer the question of the analysis. So let's say we want to know if the customer is low risk or high risk, if we should give them the loan. And we only have things like their date of birth, the size of shoes that they wear, or the color of their hair. That doesn't help figure out if they're low risk or high risk. we might need something more that's more related to the question. So we would need to include an additional attribute in or augment the attributes by adding another one in there. So find important attributes and value ranges. Now, we might be having too many attributes. That's another problem. If we have way too many attributes, that's called curse of dimensionality, and that can choke any of the algorithms that you have seen, any of those. If we have way too many attributes, the algorithm can literally choke and take forever to finish and to produce any results, especially if the data has millions of records. So the number of attributes need to be chosen properly. If there's something that's not needed, definitely remove it from the data. So that is what the data preparation includes. Once we're finished with all that stuff and the data is ready, we can select the model that we would like to use, train the model, extract the knowledge, and finally present the knowledge to the user and see how they're going to use it to their advantage. Okay, so that is what the data cleaning and preparation includes. I wanted to look at some example classifications and clustering.